Hey everybody, and welcome to the Tanzu Build service session. I'm Owen Penso, I'm a technical leader in the emerging technologies team, and let's get started. So first things first, the Tanzu portfolio. VMware Tanzu has announced a portfolio of products to basically modernize your application supply chain. So not just creating the application, build that, develop that, but also ship that into Kubernetes, manage Kubernetes, Kubernetes inside vSphere, and then how do you manage that across different clouds and different infrastructure providers with the Tanzu Manage. Now, the reason I'm saying all that about the portfolio is just to put the Tanzu Build service in perspective. Tanzu Build service as an offering, as a service, is aiming for building your application, creating the binaries you need to ship that into Kubernetes, any Kubernetes. And that means that that pillar of the build is abstracted from the run or from the manage. You can build with Tanzu Build and then push that into OpenShift, EKS, AKS, GKE, any Kubernetes cluster that you want. And you don't have to use the Tanzu Build service as a pipeline. You can use different pipelines like Jenkins, Azure DevOps, and other tools just to use that service and offering. And that's why I'm emphasizing that. So that's Tanzu Build service. And now let's go back and start from the beginning. Now, to talk about the build side of the application modernization supply chain, we need to start with containers, right? So containers is basically the starting point. And containers is the infrastructure component that basically supports that kind of a microservice architecture, the change of the application architecture. So if your application is getting smaller and basically breaking into pieces, to basically iterate and to get velocity of versions into production, that small chunks of code need infrastructure for that. And that's why we use containers. So containers is not something new. Containers has been around pretty much since the Unix and Linux kernel time, so 60s, 50s even. It was introduced recently again by companies like Docker and Rocket and Containerd and others. And all of those different projects are basically leveraging containers again as that infrastructure component for that development landscape. Now, the reason I'm saying that is just because when you build containers, when you build for containers, it's not like building for traditional OS layers that you know of right now. Let's talk a little bit about the difference between the two. So if I have like a virtualization environment, I have my VMware, I have my ESXi, I have virtual machines on top of that. If I'm a developer and I'm writing code, committing that into a source control, now the pipeline of that code is starting to basically initiate, right? The first thing is to build that code into a binary, but that binary needs the environment or the application environment to run on. That application environment are different dependencies, binaries, libraries that code, that application needs to basically run on that OS. And of course, we have the OS and we have the hypervisor underneath. Containers took that part and basically squashed that into one container. Now, if you think about it, that's the most complex part in shipping your code in production, right? The code can be in a specific language and you can be consistent with that and you can do source control for that code and you have everything you need to build that code. But if you're shipping that into different OSs, or if you want to upgrade OS, or if you want to patch something in the dependencies and everything else, that was the most complex part about shipping your code in the traditional environment that you have right now. So just creating the application environment was the most amount of time that you invest in pushing the code into production. Application containers, in containers, you basically squash the application dependencies and the OS into a silo, and that silo can run on anywhere. How? It's running with some container host that will run those containers regardless of the kernel OS of that container, and of course the application dependencies and the code itself. That allowed developers to be focused on code. And that's why developers love containers, because they can ship faster between development, tests, and production, and they can develop in their own PCs. They don't need anything special. They can develop anywhere. They can compile that container image, and then push that into their organization and use that as part of that pipeline. So if we like again, going back a little bit about what they did before that container world, it was a ticketing system, right? They've opened the ticket, they got assigned with a VM. That VM had to be configured with some kind of configuration management, Chef, Puppet, Ansible, something like that, just to create the application environment, the application runtime. And then, of course, the web platform, in this case, Apache, and then pull of that code, and then they got the application up and running. All of those different phases should have been taken care of by the IT before actual code was inserted into that environment. Now, in containers, they can do the same thing by running one command and just pulling that Docker image from the web, right? So they're just pulling Docker image, exposing that in port 80, bang. They have the same web page up and running, and they can browse that. But isn't that exactly the same problem that we had with traditional? So from one hand, we are getting the velocity, we are getting everything, we are running faster, we don't have any dependencies to that VMs or OSs. We can run those containers on clouds and on premise, on anything that has a container host. But when you get that into production, don't you have the same problems in the day two of that application? Because those kernel OSs inside that container and the binaries, libraries, dependencies of the application inside the container itself, isn't that something you need to patch and manage and basically make sure it's not vulnerable and do all the things on the maintenance side of things that you need, just like in traditional environment? Because okay, you squashed your container and application runtime and OS into an image, and you push that into the registry. But that kernel OS inside that container can also have vulnerabilities, right? Like Alpine, if you're using Alpine Linux, if it has an SSL that is exposed in with an application web, that OpenSSL can have vulnerability that you need to patch. So you still need to manage that OS layer. And what about the dependencies? If I have some dependencies that I need, and now I have some vulnerability in the Apache or something else, also something that we need to basically take care of. So we got into a good position in the infrastructure side where we are not relying on anything else for the creation of that flow for the pipeline, and we are not dependent into one infrastructure to run our code, our application. But it's not taking every problem vanished, right? We still have problems, and we still have day two iterations. So let's talk about how do you build that application. So you have that code, and basically what you're creating is a Docker file. That Docker file represents everything you need to basically create that container image. So we've said that everything is being squashed together into a container, and that means that I need to specify for that container which kind of kernel OS I'm using, which kind of application dependencies I need, what's the code that I'm pulling, and basically creating everything in a single file so I can create a container image. That container image will be tagged with a specific tag and then pushed into a container registry. That container registry will basically source control the image just like you're source controlling your code. Why do you need to source control your image? Exactly because of the things that I've said. That container image will be changed along the time with different layers, not just the change of the code. So if you're committing a new code, a new change for your code, it's obviously going to create a new container image because you've changed your application. But that's not the only change that matters, right? If something changed in the layers of that container image, in the dependencies or the OS, you need to create a new version as well. And that's why you're saving everything in a container registry. In our case, in the demo, in our presentation right now, I'm going to use Harbor for that. Now, when I'm basically creating that Docker file and I'm creating that Docker build, that Docker build will create all the things that I need, including the dependencies, the application, according to what I've specified in the manifest. And now I have an OCI image. OCI is an open container image. It's not just a Docker image. OCI is an initiative that basically opens up everything to a common ground. So it's not Docker image, a container D image, or a Rocket image. It's basically an open container image initiative. So now that I have that OCI image, I have that open container image, and I can run that on Docker host, containerd, or anything else. And now that I have that image inside my registry, what happens if something changed? If something is changing in the dependencies or the operation system, nothing will be changed in that image, because a Docker file or a Docker build is a one-time event. I'm creating that image once I'm running Docker build. That's okay, I've built that. Now, if I'm changing the code, of course, I'm gonna run Docker build again. But again, that's gonna be one time for that build. It's not a recurring event. It's not something that is manageable. So what's the problems with that? There's different problems with the way that we are building containers right now. I'm not even getting into how do you run that and what's the challenges in managing Kubernetes as Kubernetes and multiple Kubernetes clusters. That's just the build. So in the build, you have a problem of security. I've just said that. If you have vulnerability, you need basically to rebuild your entire container, and you do that manually, and then you push that manually. And if you think about it, when you're doing a Docker build, it's basically building the entire container from scratch. It's not decoupling the layers, and it's not addressing each layer individually. It's just addressing that container image. So if you're building that, it's building everything together. It's not as secure as you want to, because now if you have something that needs to be taken care of, you need to do that again manually. Developers' efficiency is getting hurt because, again, they spend too much time in understanding which kind of dependencies they need, how they need to configure that, and basically the reason we went into containers, developers went into containers, was to reduce the time they hassle with infrastructure and just be able to focus on the code. So developer efficiency is getting hurt because of that different infrastructure and security aspects that we need to take care of. CI sprawl, so the way that you're basically creating that continuous integration, you're doing that again. It's a one-time event where you're creating that application, that Docker file, and if you need to rebuild it again, you will need to run again that command. It's not something that is automatic. It's something that you need to manage basically. OS and middleware, we've went over that, the problems that we have with those layers, and if something changed in that layer, and of course transparency and auditability. So let's talk about Tanzu Build Service. So the way Tanzu Build Service is addressing that is by leveraging Kubernetes itself. Kubernetes knows how to act according to a manifest in the best way they can, right? In the best way we know. It's like an application platform that is basically built for running platforms, not just workloads. So Kubernetes can be introduced with new objects, and those new objects of Kubernetes can be managed by Kubernetes controllers. So Kubernetes can create and manage objects that I'm introducing to that platform. What if we're gonna introduce to that platform an image, a build pack, and we will get to that. And all of those different objects will eventually gonna create a pipeline of the continuous integration inside the same Kubernetes cluster that I'm running on, or in a different Kubernetes cluster, but as a service. So basically, Tanzu Build Service is doing the same thing as Docker Build, but it's doing that automatically, and it's doing that continuously. So once something is being changed, not just in the application itself, not just in the code, but in the code or in the dependencies or in the operation system or in any ecosystem of that container image, the build service will automatically reinitiate that build, and it's going to create a new version or a new revision of that container image inside that container registry. Now, I'm just going to pause for a second. If anyone has any questions, I'm following the Q&A and I'm following the chat. So be my guest and ask. So let's talk about the pipeline, because the build is just one of them, and we will get into what the Tanzu Build service is doing inside that pipeline as well. So if I'm trying to simplify a pipeline in Kubernetes, as I said, it's not like a pipeline in traditional infrastructure, right? It's a little bit different because we are creating different binaries and we are addressing those binaries differently. So if I'm committing a change in the code, and I'm basically committing that into a Git repository, that commit is now need to be compiled. So that code, that application should be compiled. I should create a container image with all the dependencies in CoreOS, just like we saw before, and I need to push that into an image registry. Now that it's inside that image registry, now I need to pull that inside in the CD part, in the continuous delivery part, and basically publish that or promote that between different environments and push that to my production environment. And yes, Tanzu Build Service is based on KPack, but it's also based on cloud native build packs. So those are the two components, open source components of Tanzu Build Service, cloud native build packs, and KPack, and I will get to which one, what's those two, and how does it work. But it's an important question and an important note. Tanzu in general has a lot of different open source projects that we are leveraging inside our portfolio. We are supporting that as an enterprise product, and we are contributing to that. So each and every one of the open source projects that we are leveraging, we are also have engineering effort in, and we are supporting and contributing back to the community, and everything is upstream. So we are not changing or forking anything. It's aligning with the community 100%. So the Tanzu build service is doing this, the left side. So basically the build part, it's pulling from Git, it's compiling with buildpacks.io, and I think now is the time to talk about a little bit about buildpacks.io. I will get to that more in the next couple of slides. Buildpacks is the magic behind Tanzu build service, and it's basically the magic behind the build itself. Buildpacks started way long ago with Ruko and Pivotal, and it was evolving in the last couple of years. And it's basically the magic of detecting your code, getting the compiler for compiling your code, compile your code, and create that binary. So according to the code that you're developing in, the build itself or the compilation itself will be happening automatically up to a point where you have that container image being packaged as a container image. So that means that I'm detecting the code, understanding understanding which kind of code it is, compiling that, creating the container image with the dependencies, and pushing that into the registry, into the image registry of your choice. And there was a different evolutions of that build packs. And Paquito is the open source or the cloud native build packs that Pivotal created and maintained. It's again an open source project, and you can check it out online. And same goes for buildpacks.io, and basically every open source project of those can be leveraged as part of Tanzu Build Service to basically build your application and push that into an image registry. And I will get to that. Of course, we will see that in the demo as well, everything that I'm saying right now. So in our demo, by the way, because Tanzu Build Service is stopping in the CI part, so it's basically not doing the deployment, I'm going to leverage a Concourse for the deployment. So basically, I'm going to leverage Concourse as the pipeline to watch for any change in my registry, and then push that directly into my Kubernetes cluster. So let's go over about like that the build packs and the architecture of that. So the first thing inside of that Tanzu build service that is, of course, leveraging KPack, as I've said, and buildpacks.io, is the stack. So the stack is basically representing the dependencies, the OS, all the different things you need to get the application running, the application runtime. The second pillar of that is the store. The store basically represents all the build packs that you're using to build your code. So in store, you can have different kind of languages that you can add, that you can compile on. The most common one is supported, so Go, Ruby, Java, Node.js, PHP, .NET Core, and others. We will get to that in a couple of slides where I'm saying exactly what. But again, everything is open source, so you can just get into the Git repo and check it out. Now, those two different pillars create a custom builder, and that custom builder is basically the one to get that code or the change from the stack, and according to that, initiate the creation of that image. Now, that image is a KPack object. Basically, everything is a KPack object. So KPack is the one to manage everything with CRDs, with a custom resource definitions of Kubernetes. I've said that Kubernetes is basically a platform to run platforms, and you can introduce new objects. So all of those things are Kubernetes objects. A stack is a Kubernetes object, a store is a Kubernetes object, a custom builder is a Kubernetes object, and an image is a Kubernetes object. And we will get into the demo where I'm actually going to create a new image. When I'm creating an image, I need to declare what's the repository, so what's the tag of the image that I want to build, and what's the source code. And according to that, I'm basically building all the other things with the default stack and the store that is related into the code that I'm writing. Now, I'm going to stop my my presentation once in a while just to see if there's any questions, and I see there is one. I would be interested to know how TAS and TBS are integrated. Maybe out of scope for this session. Okay, so I'm going to say just one sentence about that, and we can definitely create a new session on TAS. So Tanzu Application Service is an evolution of Cloud Foundry application platform, which was Pivotal Application Platform, and now Tanzu Application Platform. Tanzu Application Platform, in the next version of that, and it's in a couple of months, will be running on Kubernetes. So we have a version of Tanzu Application Service for Kubernetes. That means that basically we are replacing Diego and Garden, all the different mechanisms that was inside Cloud Foundry application platform, into Kubernetes and Cloud Native Computing Foundation projects. Now, Tanzu Build Service is the first step of Tanzu Application Service for Kubernetes. So when you're pushing your code into Tanzu Application Service for Kubernetes, you're basically doing that build, and then the TAS, the Tanzu Application Service, will also do the deployment, not just the build. So we are focusing on the build. I'm focusing on Tanzu Build Service, but it's exactly the same mechanism that will be part of Tanzu Application Service for Kubernetes. So when I'm creating that image, basically it's going to initiate a new build. That build is also a Kubernetes object, a build. That build has all the different things that it needs to basically compile the code. So it understands which kind of store does it need to use, and it understands what the dependencies and OS from the stack. And the image itself will say, where should it run? Now, that build is running inside a pod. And that's important, because if you think about it, the way that you're building right now is with some kind of builder, right? A server that basically builds. So if you're running your builder in different servers, or if it's up and running all the time, that's not efficient. You can be more efficient with that. That build is being created inside a single pod, and once that build is finished, the pod is vanished. So it's basically a pod that runs one job. It's not one, it's 6 jobs, and we will see that. 6 steps of that build. Once it's finished, it's just killing that pod. And that's for any language that I've just mentioned inside those cloud build packs. So that's really efficient way to create a build pipeline for your organization, because there's no waste of resources just lying around waiting for that build. Once it's finished that build, it's going to push that into the registry. In our case, it's going to be Harbor. Harbor is our open source project that we've contributed fully to the community. It's part of the CNCF. It's a matured project in the CNCF, in the Cloud Native Computing Foundation, and we are really proud about Harbor being matured, and it's one of the best registries out there either way. So that's what I'm going to use. You don't have to use that. And again, inside Harbor, you have enterprise mechanisms and like vulnerability assessment and signing option and syncing and others, but you don't have to use Harbor. Any registry will basically do. By the way, on the source side, so I'm going to use a Git repo, but I can also use a local folder, and I'm going to do that as well. So I hope that we will have the time, and I will show you where I'm pulling my code directly from a folder that I'm developing in, and then creating that image from a source code that is inside my laptop. Because if a developer wants to build on his own laptop without I don't know, source controlling or Git or something like that, it's not recommended, of course. But if he wants to do that, he can build directly from a folder. So if something changed in that source code, it will reinitiate that, and it will create a new build, and that build will create a new image. But also, if something changed on the stack, on the dependencies or the OS, it's going to do the same. So it's going to create a new build, and it's going to basically push that into the registry. Yeah, so that's a pipeline basically where we are gonna commit a change. It's gonna get into the Git, and that CI will pull and will create the build service automatically. The build will push into a Harbor, and then I'm gonna use Concourse, not Jenkins, in my case, to deploy that into my Kubernetes cluster. So why Tanzu Build Service? Easier deployment, hardened dependencies, and world-class support. Those are the three main value proposition of Tanzu Build Service. And it's taking care of a lot of different challenges you have just on the build side, regardless on the way that you're running your containers and the way that you're managing containers. Okay, so that's our demo now. Basically, our demo is going to be built on a Node.js app and a simple app, just running one phrase, and I will show you that. I'm going to commit a change just to show you that pipeline running. So once I'm committing a change, it will initiate a build. That build will be pushed eventually to the registry, and then I'm going to use Concourse to run that on my cluster. Okay, so I'm gonna pause here for a minute or two, just to be able to answer questions before I'm getting to the second phase of the demo. Any questions from anyone about what is Tanzu Build Service, how it works, before I'm getting into the demo? Q&A, chat, something. Okay. I don't see anything, so we can keep going. And if there is anything, you can just post it in the Q&A or the chat. So let me just describe what you see here, and then we will get into details. On the right side, you see Octant. I don't know if you know Octant. If not, I will strongly recommend you to familiarize yourself with Octant. Octant is a open source developer UI that you can download and install on a Kubernetes cluster. And basically, it's going to represent, it's going to read your kubeconfig file, and it's going to let you manage all your different Kubernetes clusters. So you can open up here, and I will see all my clusters and all the namespaces inside that cluster. And then I can manage either the application side of things, so the namespace level, namespace overview, workloads, and so on and so forth, or the cluster level, and that's cluster overview, namespace, and other things. In this case, I'm just going to use Octant to show you in a visual way the build and the way that it's building that container instead of the console. But we can also see that on the console side as well. There's another question. Is TBS running on TKG in this demo or TKGI? Well, I'm going to be a little sophisticated with the answer and say it doesn't really matter, because TKG or TKGI runs upstream Kubernetes that is open and not forked. In this case, I'm running on TKG, but it doesn't really matter. By the way, for Tanzu Build Service, it doesn't really matter if it's TKG at all. It can be anything you want, EKS, AKS, GKE, as long as it's conformant and running the conformance version of Kubernetes. So I have another question on the chat. How you are managing database services, any DB as a service offering on Taz? So that's another conversation. I don't want to get there. There's a lot to say about that. Definitely yes. Tanzu has a Tanzu service, data services, a pillar inside of that. We have data services as part of Tanzu. We also have a marketplace with Tanzu application catalog that is connected into Tanzu application service. There's a lot to say about that, and how do you handle data services in Kubernetes, and how do you combine that into a single solution? But because it's a Tanzu Build Service session and it's a Tanzu Build Service discussion, I want to keep with that, and I really want to show you the entire demo. So I'm going to focus on that. Okay, so on the right side, you can see my cluster. That's running on AWS, by the way. I've said it's running on TKG, so it's running on TKG on AWS. So basically, it's running on EC2s, but that's an AWS cluster. So I have my dev AWS Tanzu Build Service, and I'm in the builds namespace. So basically, I'm in a namespace inside my Kubernetes cluster. And lost connection. Let's refresh that. And yeah, connectivity issue. That's the best thing I can have right now. And just a sec, working from home thing. Just a sec. I hope that you can still hear me because it seems like my internet connection went down.
We can hear you perfectly, Oren.
Okay. Just a sec. Bear with me for a second. There you go. I'm back. I guess it was just a glitch. Sorry for that. And the corona is, affecting us all, including my internet connection. So I'm just gonna run Octant again. Octant. And yeah, okay, it's already running. Okie dokie. Sorry. Okay, so the application that we will use is, as I said, the Node.js. Let me just rearrange my screen. And that's application. It's just printing hello world, no Tanzu Build service demo. And that's application in my Git. So Node HTTP. And what we're gonna commit as a change is the simple change that we can do is basically changing the index HTML. So we're gonna change that line when we are ready to make a change. And my harbor is the one that I'm pushing my image to. So basically inside the harbor, I have my OpenSO project, and inside of that, I have my node repository. And inside the node, I can see different container images that was already been created before that, just to run that application. I can also delete that and delete that. Yes. So just so we see a new one getting in, and it's clean blank right now. As I said, I'm going to use concourse. So concourse is going to basically point into that container image repository. And once I'm going to push that a new repository, it's going to deploy that into my Kubernetes cluster. And the pod itself is running on the same cluster that I'm building, but of course it doesn't have to be like that. And in this case, it's running on my default namespace inside the same cluster, if it's gonna run. Yeah, okay, so that's my node. That's the application, and it's 48 minutes ago, and that's the one that you see here. Okay, so basically, let's start by creating that. Let's see the components that we have. So as I said, I'm using KPack and Buildpacks.io as part of my Tanzu Build service. So I'm going to use KPCLI. KPCLI allows me to basically create that image that will understand which kind of code I'm using, integrate the dependencies, create that image, and push that into the registry. Of course, to interact with my registry and my Git, I need to create secrets, basically just to authenticate and to create that connectivity. So if I'm getting secrets, secret list, sorry. Okay, so you see I have one secret from my Git, from my GitHub, and one secret from Tanzu World, and that's harbo.tanzuworld.com. That's basically the secrets. And another thing that I can list is my cluster builder. So KP, CB gonna be easier, CB list. So that's the cluster builders that I have. And each and every one of those cluster builders has different languages that you can use. The base and default has the most common ones, but I can add a specific. I can check, I can list the same for cluster stack or cluster store. As I said, the stack is more the dependencies in OS. The store is more basically the languages that is supported, the Buildpacks.ios that I'm using. Now, the things that the way that we will basically create now that, let's try open Octant again, just to see if it's working. Yes, okay. So what I'm gonna do now is I'm gonna create an image, but I really want to show you that in a visual way. So what I'm gonna do is I'm gonna change into my namespace of builds. I'm gonna declare, or I'm gonna state my image on the console, and then we will see a new pod that is being provisioned on the right side. and that pod will basically create that build. So first of all, I'm basically declaring that image. I'm gonna create and a KP image create. I'm gonna call it node because we are creating that node.js. I'm gonna state the tag, so that's basically the container image. So harbor.tanzuworld.com/openso/node. That's the reference to my registry and my repository inside of that. And now I'm saying go to Git to pull that code, and the Git is http github.com/openso/node http. And I want to build that image. I want the builds and everything around that image to be in builds namespace. So that created an image, and you can see on the right side, there's a new pod being created, and node build one. Now that node build one is being basically it's building my code. If I will click on that pod, you will see the different steps. As I said, there's 6 steps. So you can see init container, prepare, detect, analyze, restore, build, and export. All of those different 6 steps will basically create all the flow that we've just said. So it's going to detect my code, and it's going to, according to that code, compile that. It will pull the dependencies and OS that it needs, create a container image, and push that into Harbor. How can I see the logs or even more details on that? I can do kp build logs in the namespace builds for node. And that's basically going to bring me that logs. So here you can see in a verbose what's going on in the backend. So prepare, basically just understand the secrets are okay. Detect, understand which kind of code, and basically decide which kind of builders do I need. So it understands it's a Node.js app. It pulled the Node engine, Node install, npm install, npm start, analyze that, and then started the build. So basically, that's the build of the Node application. And then the export. So in the export is adding a different layers that it needs and exporting that, and the build is successful. So I'll do kb build list -n builds node. You will see I have one build that is success. And if I will click on my namespace overview, you will see the pod is gone. If I will change the phase into succeeded, you will see all the pods that was part of that build in the past. So basically, I don't have any running worker right now that runs as part of that pod. And if I will clear that and I will get pod, you see that terminating, and you see that 29 seconds up. The reason for that is if I will go to my Harbor, I have a new container image in my repository, and that initiated the concourse to basically push the code back into my cluster. So that's a concourse, and it runs just 29 seconds ago. So that's the initial build. So I've created the image, I have that running. Now let's commit a change. So if I will go to my repository, my Git repository, and I will change that to something else, the easiest way is just to change here. So I'm just going to do that here, and we're going to do a change that is test, test, test. Just a simple change, and I'm going to commit that change. Now, that commitment of the change will automatically initiate a build. So k build list -n builds node -w, or watch. Let's watch for that. Watch. So it didn't start it yet. It's going to take a couple of seconds. If I will go back to Octant, when we will see that build, we're also going to see a new pod being created, and it's going to be build number 2. So it's going to, the name will refer into build number 2. I've committed a change, right? Yes, it's committed. And so it's a waiting game, just a couple of seconds. And you know, when you do a demo, it's always taking longer than expected. So yeah, let's wait for a couple of seconds. There you go. So that's the building number 2. And if I will refresh that, you will see the pod that is being basically created. You can see the first one is config, by the way, and the second one is commit. So that build was initiated by the commit in the, come on, Octant. So again, not part of Tanzu. Octant developer UI should be better, but we still have a lot of different things to work on as the community. So the second build is up and running. If I will go to Harbor and I will refresh the screen, you will see a second image. And if I will now, you see that's the second image. And if I will kp build logs minus n builds minus n, not minus n builds node, you will see that second build. There you go. And if I will go to my concourse, you see it's right now deploying my second image. So if I will get pod, you will see one pod is terminating and the other one is already running for 4 seconds. That means that if I will refresh my application, you will see test, test, test. So that was a full circle. We've committed a change, automatically created a build, a new build. I didn't do anything. That build pushed a new container image, and that container image was being pulled and deployed by concourse. Now, I've committed a change of code, but it's exactly the same thing as if something changed on the dependency or the core OS of that container or anything else. A question. So this time concourse triggered the TBS build job. No. So the only thing concourse is doing is listening to the registry, and if a new image is being pushed, that image will be deployed on my Kubernetes cluster. Concourse is doing the continuous deployment part. The trigger of that build part was just because I've changed that code. And when we've created that image, we basically referred into a Git repository. That created an admission controller that basically listens to that Git repo. If something changed with that Git repo, it's automatically creating that build. So it's not related into Concourse. That's Tanzu Build service. You can use anything else you want, not Concourse for the CD. You can use Argo CD. You can use Flux. You can use Jenkins. You can use whatever you are using for the GitOps and basically to the deployment side of things. Yes, so another thing that I want to show you is basically taking that code not from a Git. So let's create another image, and for that I'm going to use a different code. Let's see if I have that here. Yeah, so I have that here, and let's see the cut index. Okay, so basically I'm creating a new one, a new image, but I'm creating that directly from my source code, and I'm gonna push that into the same registry. So it's basically gonna create the same exact thing, but I'm gonna tag that in a different way. So to do that, the only thing that I need to do is basically kp create image create, sorry, image create, and let's call it node2, and I'm gonna tag that, so harbor.tanzuworld.com and minus local path and just a dot minus n builds. So that created a new image, node2, and okay. Harbor.tanzu. Yeah, I didn't tag that right. /openso/node. My mistake, sorry. Okay. So now I've basically created a new build, a new image, a new build, a new everything with the name node2, but I'm pulling from a local path with a dot, so it's going to do the same thing all over again, and it's going to push that into the registry. So I've answered that. Any more questions? we have like 10 minutes, and I really want to answer your questions if there are any. If not, we can maybe show you TAS for Kubernetes. But any questions before I'm getting into something else? Okay, so what I'm gonna do now is I'm gonna change to my TAS cluster. I just wanna show you something. And again, it's not it wasn't part of that session, but we have 10 minutes, and I can show you TAS for Kubernetes, so Tanzu Application Service for Kubernetes. I can actually use that to push the application and to show you the same application pushed into that cluster. So does Concourse, Jenkins, etc. supports integration with Tanzu Build service? Of course they do. And it's basically Concourse, Jenkins, everything else will use either KP CLI or kube control CLI. By the way, that's an important note. So if I will change back into my TBS cluster, dev AWS TBS, and I've showed you everything that I'm interacting with KP. So KP image list minus n builds, and so on and so forth. So KP builds and everything else. But that's just Kubernetes. So I can also do kubectl get builds, and the namespace builds. And I can query for Kubernetes objects without KP CLI, without anything else, because eventually those are Kubernetes CRDs. I can use Kubernetes and Kubernetes control plane, like kube control API, to interact with those objects and understand what's going on, including describe, logs, and everything else. And another question, how do I push these to vSphere? So vSphere has the capability of Kubernetes services inside of that, so vSphere with Tanzu. You can either build and push directly into your supervisor cluster, that means the Kubernetes services inside vSphere, or you can create a Tanzu Kubernetes grid on top of vSphere and then leverage that to basically push your code and as an endpoint for that code and application. So it really depends on what you want to achieve. So yeah, last thing. And I'm going to change my cluster into my Tanzu application service. See if it's running. I have several connectivity issues today. So let's see. And yeah, we said last thing. So last thing. Okay, so I have my Tanzu application service for Kubernetes. Use gone. And in this cluster, I have my Cloud Foundry application platform running on Kubernetes. And you can see I have the same namespaces as you saw in Tanzu Build Service. So Build Service, I have my KPack, I have everything you saw in Tanzu Build Service. But here, I can also push different applications. So it's not going to just build that. It's also going to push that and expose that. And to do that, I'm basically going to do CF push. And I'm going to do that on my same node HTTPS. So cat manifest. And in my manifest for the Cloud Foundry platform, I'm just saying that's the application, that's the amount of memory, and that's what I want for the route. That's it. If I will cut the index file, it will expose the same application, hello world, but it's going to say Tanzu application service demo and not Tanzu build service demo. I don't have any concourse pipeline here. I'm just going to do CF push. Now that CF push is going to take that Node.js app, and it's going to build that in just like Tanzu build service did, and it's going to push that just like the concourse did. But it's going to do that in a single instance, so in a single flow of the application platform. If I will go to the same cluster and I will change my namespace into my CF workload staging, that CF workload staging is basically where the build happens. So just like you saw in my case in the namespace builds, you saw a pod running with 6 phases. That in Tanzu application service for Kubernetes, it's running here. See that? There's a new pod inside CF workload staging, and that's building my app. exactly same stages as you saw in Tanzu Build service. So prepare, detect, analyze, restore, build, and export. Now it already built that. Now it's pushing that into the platform to basically expose a new application. So the difference is it's not just building my app, it's doing everything. Now let me just refer into several questions in the meantime when it's pushing the app. What's the name of the tool on the left? It's rather small. So this one is just a mobile Xterm. It's just a terminal that I'm using to connect to my different clusters. Please make this recording available and notified. Yeah, Daniela already answered, so it's up. So you see on the left side, it's building exactly, you see the same logs that you saw. So it's building my NPM, creating my binary, pulling the dependencies, creating the layers, adding everything to a container image, and then it's going to run that. Now that's the difference. It's going to run that on the platform, and it's going to expose for me a URL where I can actually browse the application and see that. It's going to take a couple of more minutes. So in the meantime, if anyone has any questions, please send it over the Q&A or the chat. And I just saw we have 6 minutes left. So I hope I'm going to show you that before we're going to end the conversation. So yeah, so you see that the build was successful, but now the instance is starting. So that means that the application itself, the new application that I've pushed, that's the concourse phase that we saw in the Tanzu Build service. So now it's basically running that pod on my Kubernetes cluster. Now you see that it's already running. So the routes is this one. And let me just change my namespace into CF workloads. After it moves from the staging namespace, it goes into the CF workloads. And you can see my node running. That's my pod. And it's being exposed in a URL automatically, because that's the route that I've referred to in the Tanzu application service. And now if I will browse that, it should show me the application with Tanzu application service demo. So that's Tanzu application service for Kubernetes, and that's the entire circle of the pipeline. And basically, as I said, we are leveraging Tanzu Build service inside Tanzu application service for the initial phase. But if you don't want an application platform that is end-to-end, and you just want to leverage the capabilities of the build, you can use Tanzu Build service. And with that, I'm open up for questions, because I think that's it for today. Nothing? Okay, so yeah, there's a question. Any demo we have with TBS, TAC, TAS, and TKG all integrated? Yes, I have one of those. I call it a day in the life of the modern application. And I'm actually going to record one publicly this week or next, and I will publish that in my blog. So I can share my blog in the chat. Any other questions?
Hi, Oren. I'm sorry, I'm gonna share it again so it's available for everyone, because you shared for all panelists only. So I'm sharing Oren's blog now.
Oh, okay. Sorry.
No worries. No worries, it happens.
Yeah. Cool. So yeah, by the way, I have in my blog, if you want to get more into Tanzu Build service, there's also a blog on Tanzu Build service, and there's also a blog on Octant, and that's just promoting myself. So I'm sorry for that. That's it. Thank you, everybody. I hope it was useful. See you next time.
Perfect, Oren. Thank you so much. Your blog looks very interesting. So make sure everyone to click there and click on the Connect Learning website so you can watch the playback. The recording should be available by next week, tops. Thank you, Alfredo, for your comment. Thank you, Dinesh, for your comments. Thank you, everyone, for your participation. We'll conclude now today's webinar, and make sure to register for upcoming events. We have a vSAN event coming up and a another workloads webinar next week as well. So make sure to check those out and register. Thanks again and have a great day. Thank you, Oren, and thank you, everyone.
Thank you, everybody.
Bye.
Bye-bye.